Take a look at this window. Totally normal, right? Now watch. That's not a trick. That's not a projector. That glass just turned into a screen and then turned back into a window. And the wild part? This isn't some concept from a sci-fi lab. Right now in Seoul, commuters are riding to work behind glass that does exactly this. Today, we're cracking open the engineering hiding inside transparent displays. Tech that two of the biggest electronics companies on the planet are racing to get into your living room. Stick around, because by the end of this video, you'll know exactly why this glass can show a 4K movie, and the one tiny detail that's stopping it from being in every house on your street. Here's the part most people get wrong. A transparent screen isn't a normal screen with the back painted clear. It's a completely different way of making light. Your phone, your laptop, most TVs use LCD, and LCD needs a backlight blasting through layers of filters just to form an image. Stack a backlight behind glass and you've basically built a wall. OLED throws that whole stack out. Every pixel makes its own light when electricity hits it, no backlight, no filter layer. Which means when a pixel isn't lit, there's nothing stopping you from seeing straight through it. So if OLED pixels are basically invisible when they are off, why isn't every screen transparent already? Here's the hidden part. Each pixel still needs power, which means tiny electrodes running across the entire panel, and electrodes usually aren't see-through. Engineers get around this with ultra-thin transparent conductors, materials like indium tin oxide, wiring you can technically see through. But that wiring is also the ceiling. The more circuitry packed in for a sharper, brighter image, the less transparent the glass becomes. That one trade-off is the entire reason this tech hasn't taken over your house yet, and we'll come back to that. And this isn't some far-off prototype. LG Display has already wired transparent OLED panels into the windows of Korea's new high-speed GTX line. 55-inch panels engineered to survive a train moving over 150 kilometers an hour, showing route maps and announcements while you still see the tunnel outside. The same tech is already running in subway systems in Beijing and Shenzhen, and on trains in Japan. LG didn't stop at public transit either. Their signature OLED T is a real, purchasable wireless TV that turns invisible when it's off, then rolls its contrast layer down into the base when you want a true black picture. But OLED might just be the opening act. Samsung's answer is transparent MicroLED, which swaps organic pixels for microscopic inorganic LED chips. Inorganic means no burn-in and a much longer lifespan. And because each chip is so tiny, Samsung can pack in pixels without the same wiring clutter that limits OLED transparency, meaning a clearer, brighter picture that holds up even in daylight. When Samsung first unveiled this, the content looked like it was floating in mid-air. And as of this year, it's not just a showroom trick anymore. Samsung has reportedly installed transparent micro-LED in a corporate lobby in Seoul, with talks underway to bring it to shopping malls in India. So what does this actually look like once it leaves the showroom? Samsung's own roadmap talks about exactly this. Panels built into windows and room partitions, on hidden wheels with magnetic edges so you can physically push a section of wall into another room and reconnect it into one bigger screen. Picture your kitchen window quietly showing the weather and your morning calendar, then fading back into plain glass the second you stop looking at it. Or a bedroom mirror that's just a mirror, until it becomes your workout coach. That's not a render. That's the literal use case Samsung is designing toward. Remember that wiring trade-off from earlier. This is where it bites. Samsung's current non-transparent micro-LED TVs start around $150,000 for a 110-inch model. And transparent panels are even harder to manufacture at scale. Analysts at Omdia actually expect the transparent display market to stay fairly quiet for now, with the real surge kicking off around 2027 as production costs fall. So the tech in this video already works. What's missing isn't a breakthrough, it's a manufacturing line cheap enough to put it in your kitchen instead of a corporate lobby. And that's really the bigger trend hiding inside all of this. We've spent the last decade adding screens to everything. The next decade might be about making those screens disappear until the exact moment you need them. A window that's just a window. A mirror that's just a mirror. Until it isn't. So, which room in your house would you put one of these in first? Drop it in the comments, I genuinely want to know. And if you want to see what's coming next, that video's right there. I'll see you in it.